Hello, this is Antonio Mallarino. You have heard me talking about P&K many times. This presentation is a modification of the one I gave in the ICM conference about a month ago. I made some changes trying to emphasize some of the philosophies or concepts, that we can use for P&K management. Okay, for soil testing, of course, is one of the most important things to manage P&K together with removal when we need to maintain the levels that we want. And there are a few things that have been known for 100 years. Some test methods for a specific nutrient are better than others, or may extract different amounts across different soils. Now, this different soil has to be really different, okay? Not necessarily one series versus the other. Nutrient levels often differ for different sampling depths and may also differ for different sampling times. This happens mainly for pH and potassium. Also, the soil sample drying temperature can affect the amounts measured. This is especially the case for potassium. That's why in 2013 we introduced this field moist test or slurry in addition to the commonly used dry potassium test. And then another important thing is that P&K soil test results are indices, okay? They are useless without proper calibration with yield response. This is something some people try to get, a soil test result and transform it to pounds per acre, P2O5, K2O, that doesn't make sense, okay? There has to be this yardstick, this calibration in order to understand the meaning of those ppm that we measure. Now, I'm not going to talk about soil sampling too much today, but soil sampling very often is done in a hurry, and is the most common source of error in soil testing. People blame the labs for some mistake or some numbers that doesn't seem to be right. But most of the time, this is because of the sampling, okay? We have a large scale and also small scale, just a few feet in most fields, and the samples need to be representative. Okay, we need to split the field for sampling. Seldom a field of 80 or 100 or whatever acres is uniform in things that are important that may determine the soil test levels. So we need to split the fields for sampling. We need to study it. We need to take many cores per composite sample, even with green sampling. Some people believe because they do 2.5 acre grid sampling, it's enough to get 3-4 cores around the truck or the four-wheeler. That's not the case. And then with the predominant now chisel plow tillage, no-till, and strip till over the last 20-25 years, there is strong stratification of soil P&K. Okay, both P&K tend to accumulate close to the surface, especially P, more than K. Now, some people have this wrong idea that we need to sample shallower, we need to sample in different ways because of that, and that is not the case. The best sampling depth is the one that predicts crop response better, not necessarily where the nutrient accumulates. Okay, so, and also an important thing is that the sampling depth used out there must match the depth used for the test calibration. Otherwise, it's impossible to match these things. And then after many years of research here, Minnesota, Nebraska, etc., we recommend 6 inches for all tillage systems, okay? But the sampling is very important. People are always in a hurry when sampling. You need to consider that those that follow the test results, that involves lots of money, and need to be done carefully. Okay, we have some publications that are in the extension publication store, and also in the soil fertility website. These are two of them. These are just two figures of that soil sampling publication where we discuss, that essentially we need to move out from just the sampling by soil type, or by soil series. We need to consider the soil series, but also consider slope, erosion phases, even yield sometimes, or other things that may tell us that something may be different in the field. And then, of course, we have grid sampling, that we get more samples, but as I said, still don't just take 3-4 cores. Okay, we need to take more cores per sample, especially when people have been banning P&K fertilizers. Now, let's go to a little bit of the philosophy. That's what I wanted to discuss mainly. What is a soil test result? Okay, as I said, soil test P&K values are indices, estimate sufficiency, and don't provide the amount available. We have different methods that we get different numbers, okay, more or less. And also, only a small fraction, difficult to define, is available at a certain time. A tiny sample is taken from a very small fraction of the soil explored by the roots. So a test result is an amount proportional to what may be available during the season for crops, okay? And again, a soil test result is meaningless without field calibration with yield response that needs research over different soils and many years. Now, field calibration, people use field calibration, field correlation, and those two things have different meanings. We can talk about field calibration in general, but there are two components there. Field correlation means to relate soil test values to crop response across many field years, okay? We need to find the critical concentration or range or optimum or whatever. We also need to find relative yield responses for different deficient values, okay? What is the potential response that you get from very deficient, very low to higher values? But then field calibration per se is different. Calibrate means to find the application rate needed for a wide range of deficient values, okay? So for field correlation, sometimes we can just have a 0 and 1 rate that's high but not excessive, okay? That gives us that information. But when we want to calibrate, we need to have, this is more expensive, takes more money, more time, because we need several trials with several application rates. That's the only way that we can figure out if you have 5 ppm or 10 ppm or 20 or whatever, how much you need to apply in order to get a certain fraction of the maximum yield. Now, for 100 years, there have been two contrasting philosophies or concepts in terms of interpreting soil test results. See, and that has several implications because some people sometimes, some universities, some farmers, some consultants use elements of one or the other. Okay, the strict sufficiency level concept means that each nutrient, okay, we're talking about P&K now, has a sufficiency value or range below which crops will likely respond to fertilization and above which a response is unlikely, okay? In the strict application of this concept, okay, there is no maintenance level, okay? The fertilizer is applied when it's needed. Large amount if it's very low, lower amount if it is higher, okay? But in this concept, there is no maintenance, The concept is very common. Now, this emphasizes short-term economic returns, okay? And requires precise soil test calibration and testing, probably annual applications and frequent sampling every year or 1 year. Now, this approach is reasonable for really high fixing soils of the world and some in the United States, where build-up and maintenance is not reasonable. I mean, if you go to some areas where they have volcanic or basalt soils or tropical soils with lots of oxides, and if you say, oh yeah, I like to build up and maintain a certain level, they will look at you as if you were coming from Pluto. That doesn't make sense. Some things that are common and probably right here in the north central region are not, in other parts of the world or the United States. Now, in contrast to this concept, we have the build-up and maintenance concept, okay? Which means to build up, to apply rates, to build up soil test values up to a certain adequate level and maintain it based on removal with harvest, okay? See, in soils where maintenance and build-up make sense, okay, then this can be done, and then the removal with harvest and the application rates are the two things that determine really the trends of soil test values over time. Now, the issue with this is that how is the adequate level defined? What probability of response? So in this sense, there is no agreement. What is adequate is that you have a sufficient level high enough that is not excessive, that you essentially eliminate any chance of response, or you want to maintain a level that maybe you have a 4 or 5% response. What is it? So this method grew up from states where soils really can bank P&K. Okay, you can build up or you can draw down, which are many of the soils in Iowa, Illinois, Indiana. But this method, as I said before, doesn't make sense in soils that really have high fixation, or with bad crop and fertilizer price ratios, because it may result in excess uptake removal and increased losses from fields. Now, the predominant concept for P&K management in the north central region and in Iowa is like a hybrid, a compromise between these two concepts, okay? But some states are closer to one or the other, okay? For example, recommendations for low testing soils are based on crop response, okay? To attain either maximum economic yield or the maximum. See, in Iowa, for example, the philosophy for our rate recommendations for low testing soil have been to attain maximum yield, okay, and get a gradual build up over time, not at once, over time. Now, there are some exceptions. For example, Illinois has something very close to the concept of build up and maintenance, Kansas, for example, has a dual system. They have the sufficiency level, but then also have if somebody wants to build up and then maintain a certain level, then they can do it. And North Dakota, I believe that last year or a year ago, they changed. They have a system similar to ours, but I believe now it's very close to the sufficiency level concept, okay? Now, the issue that happened with this approach is poorly defined what soil test levels are recommended to be maintained based on removal with harvest. Now, there are two states that if you look at the recommendations, in Iowa, PM 1688, it says clearly what is that we are maintaining and why, okay? And Wisconsin also have some definitions in terms of what they do. But in other states, it's not clear. You need to look what is that they are aiming for, either maintaining a very high level where the probability of response is essentially zero, or what. And I think this is important. It's clear because farmers need to understand if we are recommending something, they need to understand why we're doing that. Now, I said several times that we have these good soils where we don't have extreme fixation, okay, of the P applied. Soils in Iowa, for example, have little or no fixation applied P and K to forms of of low plant availability. Okay, we do not have too fine texture soils. Normally we have 35, 40% clay or less. I mean, you go to other states, you go to other parts of the world, you can have 50, 60% clay. We have low levels of iron oxides or hydroxides or amorphous clays, that these are responsible for that strong fixation or rotation of the soluble P added to the soil. We don't have extremely acidic soils with exchangeable aluminum. There is none. You go to some southern states, and then you have, when you have pH 5.2, 5 or less, you have exchangeable aluminum there that is actually toxic for the plants and retains added phosphorus a lot. We don't have that. And then we do have calcareous soils that they tend to retain applied P. But what happened in our calcareous soils seldom have very high free carbonates. I mean, we have anywhere from 1, 2 to maybe 12, 15% carbonates. If you go to some of the soils that are in the border between North Dakota and Minnesota or some of the mountain states or California, you may have 20, 30, 40, 50, 60% carbonates. Those are really fixing soils, where you have to be careful how you apply. So the soils that we have in Iowa, which are about the same as in Illinois, southern Minnesota, eastern Nebraska, so forth, allow for flexible options concerning P&K application. There is no one right way of doing things. There are several different ways, depending on several things, depending on science and depending also on the philosophy of the attitude toward risk that the farmer or the consultant has. So the placement methods, moderate build-up in low-testing soil, drawdown in high-testing soils, we can do that. Okay. By the way, I'm not talking in this talk at all about placement methods, because in the last update, last February, those were not changed. Okay, we did update several things in PM 1688 in 2023. And I will just go very quick to some of the changes, not all of them, as the basis for what really comes next. We did not change the concepts, these hybrids, okay, between the concept of sufficiency level, strict sufficiency level, or build up and maintenance. We define the low testing soils are based on response, okay, and we want to get essentially maximum yield there, because we believe farmers should not risk amino deficiency, especially in the very low range. And then we define an optimum category, which in other states is called medium. But many years ago, we decided that optimum, because it's the optimum category to be maintained over time with a long-term concept of management. So we have defined these categories, very low, low, optimal, high, and very high, based on probability and size of the crop response since 1996. Before that, we were considering that, but we're not so clear as we did it. So very low, we have defined it as about 80% probability of a very large response and profitability, okay, or more or higher. The low category, we define at about 55% average probability of a moderate response and profitability. The optimum, as I said several times, is what we recommend to maintain over time. And we want to have in that optimum a 25% or lower probability of a small response. That way, with the removal-based application that we recommend, is for sure that there will not be a deficiency there, okay? And then the high is on average about 5% probability of a very small response or less, okay? And unlikely profitability, okay? as I usually say, when you are high and if you want to be sure, a low starter rate is much more profitable than not applying a large removal-based rates. And then in the very high, it's unlikely response. See, 1% or lower probability and zero benefits. Okay, this is the way we define these categories. Now, we didn't change either the concept for the application rates. For the very low and low categories, okay, these are response-based. Okay, we look at the trials and the responses. And the rates that we recommend, the objective is to attain maximum yield in most conditions. Okay? And then we do not use yield removal for this rate. And we do not recommend build-up rates more than for example, the 2-year corn soybean rotation. Okay, and then of course it's better to apply than apply something that too little with at least 1 year ahead of land tenure. See, farmers need to understand that as long as they have the field in 1 year, they should not cut the rate recommended for those, classes, because they will get a big yield loss in there. They will recoup that money most of the time. Now, the optimum, is based on average removal, okay? And they are ready to maintain or have a small build-up, okay? And we recommend to use the user-provided average or prevailing yield, not yield goal, okay, and not necessarily the yield on 1 year. Okay, you need to look at the 3-4 years. And I've talked about this before. I have shown lots of trends over time. There is a very good relationship between removal with harvest and soil test P or K over 3, 4, 5 years. Not very good from year to year. So farmers should not overreact for a 1 year with high removal, very high, or very low removal, things like that. And then the high category, we don't recommend anything except just a normal low starter rate for corn and wheat, and special conditions that are very early planting dates, lots of residue, cold soil, things like that. All these things are in the publication PM 1688. Now, we did not change the concentrations that we provide because farmers could analyze the grain, but it's lots of variation there. It's not worth it really. So we analyzed thousands of samples, and in 2013 we updated the concentrations and we made them so one can multiply directly the yield using a standard moisture, for example, 15% or 13 or whatever, in order to find the removal. It is important to say again that we recommend using the removal only for the optimum class to maintain. And then these concentrations have been modified so you can multiply the yield by the standard moisture times this number, so you get it, okay? And these are not average concentration. These are about the 75 upper percentile of observed concentration. We want to be sure, that we don't have a deficiency there. Okay, these are I put together some tables in PM 1688 for corn, for soybean, and the 2-year rotation. I put them in here. See, in the top, we have the interpretation categories. As you can see, the Bray 1 and the Melic 3 colorimetric, the classic one, the ppms are the same, but many labs are using the Melic 3 and measures phosphorus with ICP that they get a higher number. And I have talked a lot about this in other presentations. And then we have the Olsen, which is have the lowest ppm, but just because of the extraction is like that, and is the top recommended test for highly calcareous soils, okay? And then we have the rates. And as I said before, we suggest strongly that the farmer, the consultant, use the prevailing yields. Now, labs have told us that we need to provide a default because many farmers do not give them the yield. And if they are in the optimum, they don't know what to recommend. So we increased last February the default yields to 210 bushels of corn and 70 bushels of soybean. Okay, but this is only the default. Farmers and consultants should use the yield that they have, the average they have in those fields. Okay, just a reminder, the only issue we have with all these 4 tests that we recommend is that the bray in many highly calcareous soils doesn't work well. Okay, you have, for example, there we have three cases: pH less than 6.5, pH between 6.5 and 7.3, and pH 7.4 to 8.2. That those are calcareous in Iowa. Okay, so you see that below about pH 7.3. There is a fairly good correlation, between the test, but especially the Melic 3 and the Bray and the Olsen and the Bray really fall apart. That in many soils they don't work. We have some that works okay, but in others underestimates the available phosphorus there. And this the figure on the right shows what are the common soil carbonate levels. That's what I'm saying. These are relative, kind of low. If you go to other states, they have much higher carbonate levels. Okay, these are the classic relative yield correlation with soil test, in this case just for the Bray. And we have there the new category since February, okay? And the black is corn, the open circles is soybean, and then on the right, we have this probability response. This is what we want. We since 1996, that's what our recommendations are. This is what how we define these categories, okay? This is yield, it's the same thing, but it's response. That's relative yield. Here you have the actual yield increase. For example, in corn, in the very low category, you have anywhere from very little to about 140 bushels response in corn. And in soybean, you have sometimes very little, but you have up to 30 bushels. But then when you are in the high or very high interpretation categories, it's obvious that on average is 0 or below 0. Okay. This is potassium. The concepts are the same. The only difference is that the ammonium acetate and the Melic 3 extraction, they measure exactly the same thing statistically. But the difference is because we have these 2 methods that we recommend, the dry samples and the moist or slurry samples. And you see the ppms are different. That's why we need a different calibration. And then here we have the fertilization rates that were increased a bit, and we increase also the default yield levels. Here we have the 2 tests. On the left, we have the dry ammonium acetate, which is about the same as the Melic 3, and on the right graph, we have the moist or slurry, which again is about the same for the ammonium acetate or Melic 3. So what we did with this new category is to increase a bit the upper border, especially for the optimum class in phosphorus 2. So we decided this because there is lots of variability out there, because we believe that we should not risk a deficiency out there. And also there is lots of bias among labs, in spite of the NAPT and all this proficiency testing, there are differences between labs, and so we decided that we should increase, especially the optimum category, a bit higher in order to avert possibilities of deficiency. And then we have there the probability of responses for each of these tests. This is the same thing that I show for phosphorus. This is the actual yield increases. See, we have the relationships are not so good for potassium, no matter the test. They are better for the moist or slurry test than the dry, but they're not so good as phosphorus are. That's always the case in all states. Okay, this is what we show is the why we have been insistent since 2013 when it was introduced that people should use this moist test instead of the dry. Okay, I put there in blue soils with good drainage, green moderate drainage, and red poor drainage from moderately poor to very poor. Okay, and I put there some of the series that are common in Iowa. And why is that we say that it's important the drainage? Because if you look at the dry test, you see, it's obvious that something is wrong with many of those red points. If you look at the relative crop yield of about 70 or 75 or lower, that means that it's a huge response. They are in the low category. They should not be there. The highest response should be in the very low. So people that use the dry test in these soils, they are screwing up, okay? Because they say that it's low, so they apply according to that, but it's not low. It's actually very low. And we can see that with the moist test on the right, you see all these points for these soils are in the very low. That's where they should be. And so for the moist test, if you go across soils that have different drainage, either across Iowa or if there are different drainage within a field, then a certain ppms by the moist or slurry test have the same meaning in terms of sufficiency and needs to apply. With a dry test, that doesn't work. And actually, I look at trying to have different interpretations, different calibrations, but I mean, it's impossible. In these soils, just the dry test doesn't work. Okay, that's why we insist on the moist. And this is I have started showing this over the last year or two. See, some people out there still are insisting that we should not use the soil test that has been calibrated, that we should use for potassium, the percent saturation. We have been saying all over the north central region, no, that's not good. And this is data from Iowa for both the dry test on the left and the moist test on the right. And those yellow points, okay, those have the saturation that some people say that should be, okay, 2 to 5% saturation. As you can see, they are all over the place. They are in low testing soils. They are also in high testing soils. So the only way the percent saturation would work is if somebody is interested in selling the farmer more fertilizer than he needs. Because as you can see, it's saying that even at high levels that there is no probability of response, that they should maintain that high saturation level. So do not use this system in terms of deciding the potassium rate. Okay, now if we look at the benefits, okay, these are actual, these are not models, these are actual numbers, calculation for phosphorus. We have three scenarios. On the left, the good price ratios, okay, in the center, about maybe what we have now, and on the right, very bad, okay? So, and I put corn and soybean there with the corn is the black dots and soybean is the white triangles. So what we have here is the net returns, is the benefits, okay? It's not the return to the crop. It's not return to investing in fertilizer according to the different rates according to the soil test value. So what you see here is that it's clear that in the low testing class, very low and low, there's a very high probability of response, especially for the scenarios in the left and in the center, okay? That's why I insist the farmer should not cut there. But then when you look at the high or very high, essentially most of the points are below the break-even zero. But many farmers in Iowa, more than half, they have high or very high soil test and they keep applying removal. Why? Because they want to sleep at night, but they are losing money. if the soil sample is right, if the soil test is right, and that's why I recommend very good soil sampling, okay, then you can save lots of money by not applying fertilizer in high testing soils. Cut in high testing soils, not in low testing soils. This is the same calculations for potassium, and we have the moist or slurry K-test in the top 3 graphs, and then the dry K-test in the bottom 3 graphs. I mean, you don't need to be a PhD to see that obviously the moist test is better. The dry test is good only to tell you if you have a large deficiency that you need to apply, or if you have very high and you don't have to. But if you want to fine-tune the management and you want to make the most profits possible, you cannot use this method. Okay, you have to use the moist test that is in the top. Now, these are our recommendations. So I explain with detail what has been our philosophy and compared with other philosophies for soil test interpretation and management. Okay, now, what farmers or crop consultants do in Iowa? Okay, it's obvious that I've been in Iowa 35 years, so I know that very well. Some follow the ASU suggestion, but not many others. They don't. Okay, surveys and labs soil test summaries have shown that there are a few areas that have low testing fields or field section, and most are in southern and extreme eastern Iowa or isolated fields out there. More than half of the fields or field section test optimal or much higher in many areas, mainly phosphorus, especially in manure fields, but also potassium in some western Iowa fields. Why is this? Well, there are different theories. One is that, of course, 50, 60 years ago, except potassium in western Iowa, the levels were very low. So farmers, were used to this build-up thing, and it was okay. But they forgot that after applying many years, then the levels go up. And now they keep applying that. Okay? So what is happening out there is that most Iowa farmers prefer risking lower benefits from the application of fertilizer than a yield loss. That's the reality. Okay, and then of course more than half apply once before corn the 2-year rate for the corn soybean rotation. So what I ask you the farmer, I ask you the consultant, the dealer, what is the objective of the recommendation? Do we in the universities and do you explain to the farmers what is our philosophy? What is in our mind when we recommend a certain rate or a certain level to be maintained? Okay? The objective is to target maximum net return each year, or the objective is to assure that fertility doesn't limit yield? Does the farmer looks mainly at short-term or long-term productivity or benefits, economic benefits? So the Iowa State philosophy for P&K rates and the interpretations, as I said before, is that there is a very high probability for large response in low testing soils. Okay? We emphasize the long-term profitability of the system. And by doing this, we can adjust soil test values over time. Now, what does each farmer want? Does the farmer want really, just put a lot of fertilizer so I'm sure 100% that I will not have a deficiency? But you're losing money. Or the philosophy of the farmer, he wants to get a high return to the money invested in fertilizer, not necessarily get the highest yield or profits. You see, this is it's not soil science. This is social sciences or economics science, because people assumes different type of risks, when they make a decision. Now, we all know that it's very tough to know 6 to 12 months ahead of the harvest the rate that is needed POK to get maximum economic yield. I mean, it's impossible. Prices go up and down. So what is that the farmer wants? He prefers to be in short to assure a high return per pound of fertilizer applied. Now, this gives very high returns to investment in fertilizer, okay? But may limit yield and the profitability of the system, okay? But may be good, with bad price ratios or with uncertain land tenure. Now, on the other hand, does the farmer wants to apply to be sure the yield is not limited? Okay. Now, this may reduce the short-term returns, okay, benefits, and maybe of the system, but may work with good price ratios and safe land tenure, see, long-term, and allows for future cuts if prices become really bad, okay? So I borrowed this, Dale Latham. He was a fertility extension in Kansas State. He retired about 12 years ago. And we discussed a lot these issues, and he did a great job with this scheme. Essentially, we have two types of risk. Okay, the type 1, the risk assumed is that the net return to the last few input units is negative and reduce the maximum return, okay? So some may prefer that risk. But then we have the type 2 risk. Insufficient inputs limit yield and the long-term returns to the production system. So where are you? This is something, that farmers and consultants and dealers, they need to talk about it. They need to sit down in winter when there is time, unless the farmer needs to feed the hogs, or are in vacation in Arizona. You need to talk about this because there has to be a much better understanding of what is the philosophy, what is the risk assumed, why is that we make this recommendation or the others, okay? Now, let me show a couple of examples for phosphorus, okay? This is the top is a very low soil test, and we have a high yield response. That's the graph on the top left, okay? But then we have 3 graphs that we show the net returns. These are the benefits to investment in fertilizer. For corn at $7 per bushel, corn at $5 per bushel, and corn at $3 per bushel. Okay, I kept the cost of the fertilizer the same. So as you can see, it doesn't matter, even when the prices are really bad, there is still some profits, Now, there are lower profits. There is much more profits when the corn is $7, and then when it's $5, then when it's $3, okay? But there is always a profit, okay? Now, let's look at typical response in the optimum. It's a very small response, a low probability small response. So we have a low yield response, but then when we look at the returns, oops, now it makes a difference. If we have $7 corn, then, if you apply more than is needed, you have a decrease in the returns, but not that much. But if you have $5 or you have $3 corn, it's a disaster. Okay, so look at this. That's why we have been saying, do not cut in low testing soils, cut in high testing soils, okay? But this is the other side of the coin. Here is the same yield that we showed before, the same example. But now the returns, the 3 scenarios in terms of return, are returns per pound of P2O5 applied, you see? And then in the very low, if you apply higher rates, the returns per pound go down, see? Now, they are lower, of course, if there is bad prices. So in this case, you need to look at that, because even if you apply a lot, you tend to have lower returns per pound, but still there is a profit. We showed that before. But now look at the optimum soil test P level. That we saw that now the returns per pound are much less, you see? So what is that the farmer wants? especially dealers or consultants that talk to farmers and make some recommendation. Do they know what the farmer wants? What of these different philosophies the farmer prefers? Prefer the risk of applying more or maintaining a higher level, just to be sure that he have yields that are comparable to his neighbors, or he cares about the returns to investment. In that case, then he may not want to apply too much, even if that means having a bit lower maximum yield. You see, there is no one right or wrong answer. Now, after all that, and I wanted to talk about phosphorus and water quality because potassium is not a water quality hazard. In fact, old people like me, we get these pills, potassium, potassium chloride. So, but phosphorus is important. And I will show, I have lots of research on that, but I want to show the public doesn't like to have water like that. Okay, they don't want to have shrimp dying, in the Gulf of Mexico. It doesn't matter what we say; that's what the public wants. Okay, doesn't matter who sits in the Des Moines governor seat or in the White House. The public doesn't want bad water quality. Okay, so I talk about this in other talks. The soil test and the fertilizer rate is only one of many factors that determine how much phosphorus get out of the field or go to a stream, a river, or a lake. So we have all this in the left diagrams. We have all these different ways the phosphorus can go there. That's why, because a few years ago, we in Iowa and most states decided to go to the P index. Because if somebody's interested in maintaining good water quality, the soil test P and the application rate, that is not enough. We need to consider erosion. We need to consider if, okay, we have some phosphorus levels in the field, we have such application rate. Okay, is that phosphorus going anywhere? What is the slope? What is the erosion? Okay, all these things. So we need to use the phosphorus index. Now, this is the relationship between dissolved reactive P, that's dissolved phosphorus in runoff, with Bray when we sample 2 inches depth. And then on the right, we have when we sample 6 inches. It is obvious that there is a better relationship when we sample a shallow depth, because that's where much of the phosphorus is, especially in no-till, but also with chisel blow. But all states had been using for the P index, things like that, 6 inches, because that's the same depth that we use for crops. Now, if you look at these graphs, be the 2-inch or the 6 inches, you see that near the zero, and between 0 and about 20, 30 parts per million, all the points are all over the place. There's no good correlation. The linear increase starts at about 30, 40 parts per million or higher. Okay? So if we want to maintain a 20 ppm phosphorus or 25 or 30, really that's not a big deal for the water quality impacts, understand? But we should not be much higher than that. And that's why we have the problems with manure fields, that some people put manure and on top of that put fertilizer. Now, this is the relationship between the runoff P concentration, okay, and the rate for dissolved P, for particulate P, that's the sediment-bound P, and for the total P. So we have many trials, but we have only these 3 rates in most trials. We have 0, 50, or 100. Now, 50 is about the annual maintenance rate for consoil rotation. 100 is about the application that is needed to apply once for the 2-year consoil rotation. So look at that. We are applying a high phosphorus rate and we have conditions of high runoff. The phosphorus goes. We have some data that shows that especially when that phosphorus is applied on soybean ground, and especially if it is applied in winter with frozen soil or with snow, and if it is applied in the spring where there is a high probability of high rainfall, applying such a high rate really increases the probability of high phosphorus losses from field and water quality impact. So we need to think about it. And that's why I talked before about all these different ways from the agronomy perspective, from the yields, from the economics. Okay, there are different options. But if we consider water quality, we need to be very careful when we are applying high phosphorus rates. Now, the other thing is that we have different phosphorus sources. So this is an experiment we did in 21 fields. We were with these contraptions, rifle simulation all the fields with these guys there, my students or research associates. And you see, those are averages. And when we have no P applied, we have beef cattle manure, poultry manure, liquid soil manure, and fertilizer. The amount applied was the same, okay, 100 pounds P25. And we got a runoff event within 24 hours of the application, okay? So it is obvious that when we are applying fertilizer, we are getting the most losses. You apply fertilizer phosphorus, and you get a runoff event within 2-3 days of the application with sloping ground. The losses of phosphorus are huge. And then comes the liquid soil manure, and it's much less for beef cattle manure and poultry manure, okay? Now, this is important. Why? Because you need to be aware of these things. See, and I don't have time to explain why are these difference. It's because of the proportion of the salt P in these sources. It's because of the physical form. It's a combination of things, okay? But you need to be very careful when you are applying liquid soil manure on the surface or fertilizer. That's when the losses are the highest. So then, why would farmers apply removal-based rates or high rates to high-testing soils? Why? They are losing money. That phosphorus is not needed, okay? And they are increasing the risk of phosphorus loss to the streams, lakes, and rivers. And then, of course, we have EPA or ODNR coming in your box, for those environmental things. Okay. The key then is we need to try to increase profits while reducing phosphorus loss from fields. Okay. So suggested P or K rates maximize yields in low testing soils. Higher build-up rates than for 2 years reduces profitability. Why would anybody jump from a very low to an optimum at once? Why? The only thing it's doing is risking that P or K will be lost. It's not a good thing, okay? Recommended maintenance of optimal levels based on crop removal assure maximum yield, okay? Starter rates are much better and more profitable sleeping pill for high testing soils than removal-based rates. Higher total and dissolved P loss in high testing soils and higher with fertilizer and liquid soil manure. You need to be careful with those two sources especially. And then we have higher dissolved P loss with increasing P rates, mainly applied to the soil surface in the spring or in winter to soybean residue. So my intention was that you go into the basics of why we do things. What is the concept behind the recommendations, and what does the farmer want to do? Okay, in order to be able to achieve good profitability and reduce phosphorus losses from fields and water quality impairment. And with that, thank you very much.